This is a lesson for Algebra 2, lesson 44, third day of solving radical equations. Same steps as before. So today we're going to look at a little bit more advanced problems. These aren't the most advanced, but I'm only going to take you up to here. Okay, so number 1 and 2 I'm going to do. So please do not write right now, pencils down. Okay, so the first step is you want to make sure your radical sign is isolated. It is in this example. So watch what I do carefully. Just watch right now. You have to square both sides, okay? So you have to put parentheses around the whole right side, okay? This is the danger you're going to get into. Please watch carefully. Some students will try to do this. They'll say, oh, I'm going to square both sides, and then they put a square sign here, and then they're working it out. They're going to go b plus 4. Is this the right answer? Or is that... No, that is incorrect, right? So we have to... No, it's not b squared plus 4 either.
b minus 2, b minus 2, right?
b minus 2 times b minus 2 is b squared minus 4b plus 4, right? Did y'all see that? What's b minus 2 times b minus 2? It's just like saying b minus 2 times b minus 2. Do y'all see this now? Okay, so be careful. The left-hand side is 9b minus 36. Okay. And we combine like terms, subtract 9b from both sides. Add 36 while I'm at it. So we got 0 is equal to b squared minus 13b plus 40. Okay? So 0 is equal to, open parentheses, b minus 5 times b minus 8. I'm factoring now because I have everything together. Zero product property, we got b minus 5 is equal to 0, and then b minus 8 is equal to 0. So b is equal to 5, and b is equal to 8. Alright? So we got your two answers. Now we have to check them for if they are extraneous or not. So we got the first one. You go back to your original problem. So I'm going to erase my annotations up by my original problem so I don't get confused here. Okay, original problem, that the square root of 9b. So instead of b, we're going to put 9. Well, let me make a little bit more room. Square root of 9b, so 9 times... The first b that we figured out was 5. So 9 times 5 minus 36 is equal to b again, 5 minus 2. Okay? 9 times 5 is 45. And then we got 45 minus 36 is 9, so the square root of 9 is equal to 3. And we ask ourselves, what's the square root of 9 is 3? Is 3 equal to 3? Does this make sense? Is what we're asking. Does it make sense? Yeah, it does. So then we know that this first solution is not extraneous. It's included. Checking 8 now, so we got 9 times 8 minus 36. Square root of this is equal to b, which is 8 minus 2. So 9 times 8 is 72, minus 36 is equal to 6. 72 minus 36, oh, this is a square root, by the way, is 36 is equal to 6. So 6 is equal to 6. Does this make sense? It does, so therefore this is also a solution. So you do all that work just to make sure you have the correct solutions, okay? So that's number 1. Okay, number 2. Okay, number 2. Now this one's a little trickier, right? Because step 1, is my radical isolated? Is it isolated on one side?
No.
No. We need to isolate it first, okay? So any other terms that are there, such as this negative k, it needs to get out of the way. So we're going to do the inverse of minus k, which is plus k on both sides. First, this is your first step. So we have k minus 12 is equal to positive rad 56 minus 5k. Okay, so Square both sides. Remember, if you square both sides, squaring the left-hand side is a binomial times a binomial, so it's going to be k squared minus 24k plus 144, which is equal to 56 minus 5k, because this square root and the square cancel off. Okay, combine like terms, subtract 56 on both sides, and add 5k while I'm at it. So we got k squared minus 19k plus, what is this, 88 is equal to 0, right? These all cancel out. So we factor the left-hand side now. We got k minus, what is this, 8 times k minus 11. You do an x box if you needed to, which is equal to 0. So therefore k minus 8 is equal to 0, and k minus 11 is equal to 0. It's the zero product property. So k is equal to 8, and k is equal to 11. Okay, so we have two answers now. We need to check them to see if they're extraneous solutions. So I'm going to check the first one, which is going to be going to my original problem. Negative 12 is equal to negative k. So remember, it's negative. Our first k is 8. Negative 8 plus 56 minus 5 times k, or 5 times 8 is 40. Okay, so we got negative 12 is equal to negative 8 plus square root of 16, which is just 4. So negative 12 is equal to, let's just skip a step. Negative 8 plus 4 is negative 4. Do these equal? Yes or no? No, they don't. So this is an extraneous solution. We can't use that one. Let's try the next one. So we got negative 12 is equal to negative k, so negative 11 plus the square root of 56 minus 5 times 11, which is just 55, right? So we got negative 12 is equal to negative 11 square root plus square root of 56 minus 55, which is just 1, right? Because 56 minus 55 is 1, square root of 1 is 1. Negative 11 plus 1 is negative 10. Is negative 10 equal to negative 12? No. So, do any of my solutions work? No. So when this happens, you write no solution. You're like, all that work just to get no solution. Yeah, I know. This is a frustrating moment as a math student, teacher too. You do all this work and then sometimes your answer is no solution. Okay? Because there aren't any solutions that work. Okay? So the big thing about this is that when you're squaring both sides, you're squaring binomials, you have to FOIL them, right? Just like here, FOILing them. The other thing is, when you check for solutions, sometimes you get no solution. Okay? And then the other thing is, you need to isolate the variable. So there's 3 things that I showed you on this slide I wanted you to take note of. So I'll let you take a moment to talk to your partner. You pick who does which problem. I'll let you choose this time. And I want you to talk about it, okay? Before you write. I'll give you a couple minutes to write after. Ready, set, talk. Continuing on number, let's not do 3, let's do 4. Okay, 4. And the reason I want to do 4 is I want you to tell your neighbor what's the first step that you should do before you start anything. Okay, you do that, go. On this example, we have to add v, of course. I hope you did that first. So we get the square root of 7v plus 22 is equal to v plus 4. 7v plus 22. Shh. We could square both sides. So we get 7v plus 22 is equal to v plus 4 squared is going to be v squared plus 8v plus 16. Students, quiet please. Subtract 7v and subtract 22. So this cancels out. We get 0 is equal to v squared plus 1v minus 6. And then you could factor this. You could use an Xbox to help you, or you could just do it quickly. You go v plus 3 and v minus 2 is equal to 0. I'm writing too small, sorry. Zero product property got v plus 3 is equal to 0 and v minus 2 is equal to 0. Alright. Subtract, we get this one is going to be v is equal to negative 3, and then v is equal to 2 right here. Now we have to check our answers. Oh, it's, yeah, negative 3 and 2. Checking your answers, so going back to my original problem, I got the square root of, go up there. The square root of 7 times negative 3 is going to be negative 21 plus 22 minus negative 3. Remember, you're minusing a negative 3 or subtracting a negative 3 is equal to 4. So we got square root of 1 is 1 plus 3 is equal to 4. 1 plus 3 is 4, right? Is 4 equal to 4?
Yes.
Yep, this is a good solution then. It's not extraneous, so you would box that one. Okay, and then we check the next one. So we got square root of 7 times v is 14 plus 22. 14 plus 22 is 36 minus v minus v. This is minus 2, which is equal to 4. So we got square root of 36 is 6. 6 minus 2 is equal to 4. 4 is equal to 4. That's correct. Okay, that's it. So this is also not included. It's not extraneous, so it'd be a good solution. So these are the two answers. If you made a mistake, please fix it. I'll leave this up here. But this concludes our lesson for today.